Hi, Algebra 2. I'm not here, but you are. So I still need you to understand some content, to get some things. We're finally out of quadratics and polynomials. This last section before we start our cornerstone is all about statistics. We kind of sat down as teachers and decided before students leave the math realm, and some of you are going to be done with math after this, that there's some basic things we want you to be able to do, and statistics are everywhere. Statistics are these ways to quantify, to give numbers to facts around us and phenomenon around us, and being able to read graphs and charts, kind of like the thing you did yesterday. But there are some basic skills with stats. You've probably already seen some of them that we're going to review, and then some new ones you're going to get. So without further delay, you have a sheet in front of you called the Measures of Central Tendency sheet. There's going to be spots during this video I want you to pause and do some things on your own and then come back. Just stick with it. This is your lesson today, so do the best you can with it. So without further ado, let me change this thing over. Your worksheet should look like this. In the very first one, I already want you hitting pause for a second. It says to come up with your own definition for what a measure of central tendency is in statistics. Now, I don't necessarily need you to get on the internet, but I want you to break down the words, a measure of central tendency, and tell me what you think they mean. So hit pause, come back. Okay, we're back. I hope you did it. Not sure if you did, but I want to give you my definition. In general, a measure of central tendency. Central tendency is like a single number to represent a bunch of numbers. That's basically, that is my definition. Here, I have proof of it. Like I did a colored version and everything. So your definition should be here. Mine is a single number that represents a set of numbers, right? We have a bunch of numbers, and I don't want to list off a million numbers every time I'm describing something. I need a way to quickly and succinctly talk about a big group of numbers, and that's what a measure of central tendency is. It is the mean, the median, and the mode. We'll start with the easiest one. The easiest of the MMMs is the mode. The mode is the number that shows up the most. Mode and most. Couple weird things. There can be one mode, there can be more than one mode, or there could be no mode at all if no number shows up more than once. So there are three sets of data, right? We're talking about statistics, right? One single number to represent a bunch. I want you to find the mode for each one of those. So take a minute, hit pause, figure out what the mode is, then come back. 3, 2, 1. We're back. We're going to pretend like we didn't see it earlier, but here it is. The mode is the one that shows up the most. So looking at these numbers, we could count how many. 12 shows up the most. That's the mode. 0 and 15 both show up 3 times, so those would both be considered the modes on this one. We would call that bimodal, right? Bi meaning two, modal meaning mode. It makes sense for us, bimodal. And then this last high school, all these numbers only show up a single time, so we would say there is no mode. Easy, mode. This is a way to describe a bunch of set of numbers, right? Whichever one shows up the most. On average, their number of students taking the SAT are 12, right? A single number that represent a bunch. The next one is called the median. The median is the middle of a set of numbers. Now be careful here. Every student, at least once, will just give me the very middle number. Well, they have to be in order. So notice it says after the numbers are put in order, so descending order or ascending order, whichever one you want, they have to be in some kind of order. We want to locate the middle of the numbers. We will call n the number of data points because if n is odd, like there's an odd number of numbers. I hate saying number of numbers, but I also kind of like it. There's only going to be just a median right in the middle. It's one of our data points. I don't like the fact that I said there's a single median. There's always just a single median. There's one number, but how we find it is differently. If there's an odd number of numbers, I can cross out the biggest and smallest, the biggest and smallest, and whichever one I have left is the median, piece of cake. But if there's an even number of numbers, then there's something we call a median pair. Median pair. Because if I cross out the biggest and smallest, biggest, smallest, biggest, and smallest, I wouldn't be left with one. Where is the middle? The middle is going to be halfway between this median pair, halfway between these. So to find them, to find the single median, you have to find the average or the mean, the middle of the median pair. So we would add these two numbers together and divide by 2, and I'll let you answer this one below. What would the actual median, where is the middle of these numbers? You figure that out. Here, I'm adding something right here. Hopefully you're paying attention. If you add this to your notes, you are going to get extra credit. Good job listening. Here's the first one. In general, if n, right, the number of numbers is an odd number, 3, 7, 135, then the median is just a single number, and we can locate it, we can find it by doing this little formula. N plus 1 divided by 2. That would be where we could locate the median. Okay, let's think about it for a second. Here's a question. It says, I have an ordered list of 241 numbers. All right, the reason I'm doing this, like this was easy when it was 5. Biggest, smallest. Finding the middle is really easy. But in this situation, like I have 241 numbers. I don't want to have to cross off the biggest, smallest. So I will still want to find the median. Where's the middle of all this data? So how we do it is this formula up here. I have an ordered list of 241 numbers. Where can I locate the median? Now this answer I'm about to give you is not the actual median. It's where you can find it. It's the location of the median. Okay, 241 is the number of numbers. I would do 241 plus 1 divided by 2. 242 divided by 2, and it would be the 121st number. So on my list of 241 numbers, I would go find where the 121st number is, and whatever number that is the median. Again, it's not, this will give me a location, not the actual median. Okay, what if they're even? Right, we already talked about here, if there's an even number of numbers, we get a median pair, that is 2 of them, and we have to find the halfway point between them. So, if n is even, put this somewhere in your notes, please. The first number in the median pair can be located at n over 2. Again, when I had 6 numbers, it wasn't that big of a deal. Biggest, smallest. Okay, those are in the middle. But what if I don't have that? What if I have 144 numbers? I don't want to have to sit there and cross off the biggest, smallest, but I still want the middle. Where would the median be located? Okay, well, the formula is just n over 2. So in this case, 144 is how many numbers there are. 144 over 2 is 72. So the 72nd and the 73rd number, those would be my median pair. We already discussed right off the bat, if n is even, 144, there's going to be a median pair. There are 2 numbers in the middle, and we have to figure out what's halfway between them. So I would figure out what the 72nd and 73rd numbers are. I would add them, and I would divide by 2, and that would give me the actual median. I know for a fact, I have a quiz coming up for you guys where I have a list of numbers, but I don't give you the entire list. I just tell you how many numbers there are, and I just give you a little snippet of the list. And you have to figure out, well, where's the median? Is it a median pair? Is it just a median? Where is it located? What is it? You will have to use this pink and blue sheet, these notes you just wrote, to answer that question. Okay? Hit pause. For these numbers right down here, I want you to find the median. The median for this price of gallon of gas around town. These are all different gas stations with the price of gas. I want you to find the median, the middle gas price. All right, you're back. Hopefully you found the answer. The answer would be 3.665 would be the one in the middle. Did you remember to put all your numbers in ascending order? I don't think some of you did. I think you fell for that and did smallest, biggest. The numbers have to be in order first, so put the numbers in order, then find the median. Okay, moving on, flip the paper over. We are now at the last and probably most famous measure of central tendency. It's called the mean. The mean of the data is what you would think of as the average. And we find the average by adding up all the numbers and dividing by how many there are. Seems pretty straightforward. Awesome. Then take a minute. I want you to add all these numbers. I want you to find their mean. These represent the number of goals scored this year for our girls' soccer team. And when I said yes, really, I meant yes, really for last year. It wasn't this year. But this definitely were, I went online and found all these things for, I think it was 2020. Okay, we're back. You hit pause, right? Did you find that the number of goals was 3.27? If you did, awesome. When you're finding the mean, it's not necessary to put them in order. Only the median does that matter. For these ones, I'm just adding them all up. All right, let's put some examples to this. Hit pause. I want you to try all these to the best of your ability. Come back when you're ready, and I will go through the answers with you for all of these. Pause, please. Ooh, I know you didn't hit pause. I know you just kept letting that play. Those of you that did it the right way, here you go. I have a bunch of scores for my 8 most recent bowling games. I am trying to try out for the team, so I need to figure out what I'm going to tell the bowling coach about my bowling. Would I say I mostly shoot? Mostly shoot would be your mode, which one showed up the most. In this case, 165. I'd say, mostly I shoot 165. That's true. Next one says, on average, I bowl. Well, average is the mean. So I added them all up, and I divided by how many there were, 171.1. Finally, the median. My scores are either above or below. Well, that's a definition of median. If you're in the middle, half the scores are above, half the scores are below. So I put them in order from least to greatest, and then I found the very middle one. I have to choose which one of these to tell the coach. I'm going to go with the last one because it's the highest. If I'm trying to make the team, I want them to think I shoot the best I can. All of these are true, and you'll hear sometimes people say statistics can say whatever you want them to say. This is an example of that. Like, I have a choice of which one of these I want to report. They're all true, but which one paints me in the best light for bowling? It would be this one. I would say, my scores are either above or below a 172.5. Absolutely true. Okay. Next one is like the most famous statistics problem there is. I feel like ACT, SAT, college entrance exams, this kind of thing shows up a bunch. It says, below your percentages for the last 5 quizzes in this class. What percent do I have to score on the next quiz so that I get an A in the class? Okay, well, I'm talking average is a 93. As soon as I hear average, I should be thinking I'm going to add up all the numbers and divide by how many there are. I know my average has to equal 93. So I'm going to add all these up. 1, 2, 3, 4, 5. Plus, I have to add my next quiz. What percent do you have to score in your next quiz? So I'm actually going to add the next one. There's going to be another one I'm going to call X, and I'm going to add that to my big list. So I'm adding all these together, and I'm dividing by how many there are. 1, 2, 3, 4, 5. There are 6 numbers total. I want that answer, I want that average to be a 93. So here's what I have set up. Adding all the numbers together, dividing by 6, and it equals 93. Now I have to solve this equation. Algebra doesn't go away. It just morphs into other things. Now it's in statistics, but that's okay. We can do some algebra. All of this divided by 6. I could multiply this 6 to the other side. And this goes for all problems, by the way. If you multiply the average times how many there are, you're going to equal, it's going to be the same as the sum of all of your data points. So when I multiply this 6 over, 93 times 6, that's exactly the same as adding all of my scores together. So I'll multiply 6 over, I'll subtract each of these over to the other side to get X by itself. You could have added all these together first to get it to a single number and then subtracted that single number. Either way, you would have to score 124% on your next quiz. So sad face, you're probably not going to get an A if these are your scores. Oh well. Okay. Next one, we're running out of time here, we're almost there. It says the average age of 10 people on the bus is 34.5. If 2 18-year-olds get on, what is the new average? Okay, well, in general, to find the average, I have to add all of their ages together. But what makes this tough is I don't have all of their ages. That's okay. What did I just say a second ago? If you multiply the actual average, 34.5, times how many people there are, how many things there are, you get the sum of all of their ages. So if I multiply 34.5 times 10, I get 350. That represents the sum of all of the people on the bus. Okay, well then I'm adding an 18-year-old and another 18-year-old. So that's going to give me 386 now is the sum of all the people on the bus. We divide by how many people are on the bus, and that will give us the average. Well, there were 10 people, but 2 more got on, so there will be 12 people total. I'll do 386 divided by 12, and you end up with 31.75 years. Not too bad. One more minute to do the very last question on the back. It was tricky, but I'll kind of give you some guidance here. Make a list of 7 numbers where the mean is bigger than the mode, which is bigger than the median. The median has to be the smallest. We'll start with these two. I'm going to ignore the mean. The mean is really easy to fluctuate, but the median mode, not so much. The mode, the number that shows up the most, has to be bigger than the median. That's the one in the middle. So here's my list of numbers. Notice the mode right here, the median here. This is bigger. But now my mean is only 11. If I added all these up and divided, I'm only at 11. Okay, if I want the mean to get really big, the mean it's controlled or can be changed a lot by outliers, and we'll get into what outliers are. I can make my last number huge, and that will really affect the mean, but it won't change my mode, and it won't change my median. So all I do is change my last one to 140, really, really big. Now my mean is bigger than the mode, which is bigger than the median. Peace!